I feel so weird. Okay, this is Thursday, August 29th, 2019, the last day of the first week of school, and the first day you're getting the books in front of you. I do have to make one change to what we were normally going to do at this time. The very first lesson in your book, I'm going to do because I didn't prepare you for. Most of you probably have graph paper, but I thought about it last night. I'm like, I didn't make that announcement. On Tuesday, make sure you do have graph paper. If you do have it, don't worry about it. I'm not going to change it now because I already changed it last night. So we're going to go to lesson 2, 1.2. And what's cool about that is it kind of like is a continuation of what we just did yesterday. So that actually makes it a nice flow. So my mistake not letting you know to bring graph paper ends up being, to me, kind of a good thing because it's a continuation of what we did yesterday, which is PEMDAS or GEMDAS or order of operations. When you have multiple operations you have to do in one problem, you can't just decide, I guess I'll do this first. Or you can't just go left to right and do the operations as they're stated. We have to have one set standard for how to solve these, and this is what the mathematicians have come up with, the order of operations. So we've already kind of covered the top of the page. By the way, just like you found out in 5th grade, Mr. Frank is not the type of teacher that sits there and goes through everything that's in the textbook. In 5th grade, there's that tan box at the top in the Abeka book, right? I never sit there and go over that. That's always there for you. I kind of do it my way, and if my way you don't understand it, then you can go back to the book, look at the examples. Sometimes we will hone in on specific examples in the book, but then a lot of times I have found that students, when they're reading a textbook, it just doesn't happen for them. So the textbook, the examples are always going to be there throughout the year. Sometimes we'll do them together. Sometimes I'll just go right into diving in and doing them with you so that we're just kind of experiencing the problems instead of trying to take what's written in the textbook, because a lot of times that's hard to understand. Is that making sense? Mm-hmm. So by just experiencing it and doing it, you might learn a little better, but the stuff's always there. All right, middle of the page, on a lot of these lessons, there'll be that green box that says notebook. Now, you do not have to write it in a notebook. The intention of that is, hey, that would be a good thing to write in your notebook. You absolutely can if you got a math book going or a math notebook going, but I'm not requiring you to write that in a notebook. But someone's going to read it right now, so we all get back into this PEMDAS mindset. No, you want to read what it says there? Oh, I'm sorry, we're on page 10. Page 10, lesson 1.2. Somebody please read the green box that says notebook. See that handsome fellow down there towards the bottom? Nobody wants to read? This is middle school, the self-conscious period of your life. Self-conscious. Jonathan, go ahead.
To evaluate an expression that has more than one operation.
Okay, what do? 1.
Evaluate expression inside grouping symbols.
Grouping symbols, which is why yesterday I said some people call it GEMDAS instead of PEMDAS. So it could be parentheses or brackets. That's what I was looking for. Parentheses or brackets. 2, Jonathan.
Multiply and divide from left to right.
Multiply and divide from left to right. There's the other point of possible confusion. Do you, going left to right, multiply first, then go back and divide, or do we look at multiplication and division as one thing? We look at them as one thing. You don't go from left to right and multiply and then go back and divide. As you work from left to right, you do multiplication and or division as you go. Everybody clear? 3.
Add and subtract from left to right.
Then you go back, and these are considered together. You don't go through and add and then start again and subtract. After you've done your multiplication and division, you go back left to right, add and or subtract as you go. This is day 2 of order of operations. If you didn't get it yesterday, hopefully you're getting it more even now as we're going over it again. They left out exponents in there, didn't they?
Yeah.
But I think in their minds, exponents is another way of grouping. Like 2 to the third is 2 times 2 times 2. All right, now here's a term for you. The term is evaluate. What does that word mean? We're going to be asked today to evaluate, and that's what we did yesterday, to evaluate expressions. When I was younger and teachers started using weird words or bigger words or words that I'm like, this is math class, you're not talking about numbers. What does the word expression mean, first of all? And then we're going to say, what does the word evaluate mean? What's an expression? Why do they use that term in math class? Yes?
It's an equation with no answer. So you don't give an answer.
You don't give a, you said it's an equation with no answer? An expression, okay, what's an expression in am I expressing myself right now? All right, so an expression is just kind of like a statement. It's a mathematical statement. And what does it mean? What's it mean to evaluate? What's it mean to evaluate something?
Solve
What is it?
something, like solve something.
No. Close, but not necessarily solve. When you're solving, it's usually an equation. Dominic, you're going to solve an equation. Here we're just asking you to evaluate. Yesterday we didn't have any equations up here. If you remember the 5 problems I put on the board yesterday, none of them were equations. Were they? What makes it an equation? Has to be an equal sign in there, right? So there was no equations up there yesterday. We were just evaluating. What does it mean?
To figure something out. Or
Kind of. What root word is in the middle of the word evaluate? Jaden? Value. So, simply put, when you evaluate something, you're finding the value. And in English, outside of math, the word evaluate means to like judge something. Anybody ever done science fair? When you've gone to the science fair and you've stood there with your project and the judge comes to talk to you about your project, what are they doing? They're evaluating what you know about your science fair project, right? So to evaluate kind of means to judge, and in math, and to judge means to kind of find the value of what you did. And then they give you a score, right? Everybody got it? Okay, I just wanted to make sure because, you know, you're in math class, and when I was your age, I try to relate things like when I was your age, like I know the instructions say evaluate, I kind of know what to do, but I never really thought about what the word evaluate means. All right. Let's jump in. There's several examples there. We already did a lot of this together. All right, so watch what I'm doing. I'm already going to page 12. There are 3 examples through pages 10 and 11 that are there for you to go back to if you don't understand by the end of today's lesson what we've done together in class. You don't have to write anything yet. We're going to work through, starting at number 1 together. I'll tell you when your homework starts. And when I say your homework starts, that means you get your notebook out, and even though it's quote-unquote your homework, we actually start it together. So some of your homework, we're all going to be doing together, me and you. Does that make sense? And you'll be hoping, okay, Mr. Franklin, get done so we can get our homework done. But right now, we're not going fast yet. Number 1. Somebody read number 1. David.
Vocabulary. Use the order of operations for this in order to step. Use the evaluate solid expression. 8 plus 2 minus 5 is 50.
We're going to evaluate the following expression. That's an expression. That's a mathematical statement. 8 plus 2 times 5 minus 4. We're going to find the value of that. Everybody got it? We're going to find the value, evaluate that expression. What's the expression? A mathematical statement. Number 2. Go ahead, number 2. What's the first step you would do in evaluating that expression? What would be the first step you would do? Micah. Micah says the first thing you would do is multiply. Micah, is the first thing you're going to do there multiply because it's the first step, it's the first operation that you see? Yes? Is that really the reason you're going to multiply first? Because the first operation you see is multiply? I know. Micah, you're like, why is he asking this question? Because it's important. I want to know the reason you're saying that the first thing you would do in number 2 is multiply. And the correct answer really isn't because it's the first mathematical operation I come to. The reason, Micah, that you would multiply first in number 2 is because you have to multiply first, right? You might be thinking, yes, Mr. Franklin, we know that. But I want to make sure that you're not just saying that I'm going to multiply first because it's the first operation I come to. Got it? Number 3. Oh, I'm sorry, let's go ahead and evaluate number 2. We don't have to write this yet. We did this yesterday. We're doing this orally together. Somebody raise their hand. Tell me their evaluation of number 2. Yes, sir.
40.
He says 40. Who agrees? You first have to multiply, going left to right, 10 times 6, 60. Then you subtract 60 minus 20, 40. Number 3, let's go faster. Casey, what would be the first thing you would do in number 3? She says, first thing I would do is multiply, going left to right. So what's 5 times 15? Anybody do that in their head? Does anybody know? Do you know 5 times 15 real quick? Remember back in 5th grade when I said, you got to know your times tables through 12? But why stop there? How many ever took my advice and learned their 13s? Really? Did you learn your 14s? You learned your 15s? What's 5 times 15? 75. So the next step would be 75 divided by 3. Can anybody do that in their head? 75 divided by 3. By the way, leads me to another thing. I just said, can you do that in your head? I started telling you back then in 5th grade, and I tell every math student I've ever had, mental math makes math so much more enjoyable. If you would commit to, it makes it more fun. If you would commit to sharpening your mental math skills, which goes back to 3rd grade and learning those math facts, but going beyond that, the more you could do mentally in math, the less you have to do on paper. I mean, face it, the less work you have to do, everybody's happy. So it would be great if everyone in here, there's nothing wrong with you if you can't, just something to work on. If you could all do number 3 without writing anything down. If you could look at 15 times 5, boom, 75. 75 divided by 3, boom, 25. Think about it. Wouldn't it be so much easier and even, dare I say, fun if you didn't have to write a bunch of stuff out to evaluate number 3? If you could do that in your head, challenge yourself to get better at mental math. There are things, especially in algebra, that I have to make sure you write every step. That's just a fact. That's just the way it is. But there's other things that I'm going to encourage you. Hey, mental math. All right, number 4. 4 plus 8 divided by 2. What would be the first thing you would do there, Sid? 4 plus 8 divided by 2. The first symbol you come to is add. See why I was making a big deal? First symbol you come to is addition. The second symbol is division. What would you do first in number 4? She would divide first because, according to the order of operations rules, you have to divide before you add. Makes sense. Spencer, you weren't here yesterday? No?
Yep.
Yeah, we had 5 problems on the board, and for one of the problems, we had 25 kids in the room. Guess how many different answers we got?
11.
How'd you know?
I was here.
Yeah.
Oh, that's right, you left the 10. We had 11 different answers for one problem, and that's the whole point. That hopefully hammered the point home to you that we have to have these rules. So what is the evaluation of number 4? 8. Because 8 divided by 2 is 4, and 4 plus 4 is 8. I'm going faster now. 5. 5's got parentheses, so be careful. What are you doing, David? What would you do first?
15 minus 7.
David says he'd do 15 minus 7 first because
That is first.
parentheses, grouping. You got to do the parentheses first. So he would say 15 minus 7 is 8, right, David? Then what would you do?
And you would multiply.
2 times 5 is 10 plus 8, 18. Hopefully everybody's starting to get the hang of this. Number 6. What would be the first thing you would do in number 6, Evelyn?
Divide.
She says divide. Even though the first operation there is add, the second operation is subtract. Evelyn says, nope. I'm going to divide first. There's 2 other operations going left to right. She has to skip over. She's dividing first. So Evelyn says, I'm going to do 10 divided by 2. And then I go back and add and subtract. 6 plus 14 minus 5. 6 plus 14 is 20 minus 5.
25.
Minus 5.
Oh, 15.
15. Number 7. Uh-oh. See why some people call it GEMDAs instead of PEMDAs? Because there's not just parentheses there. Let's write that one on the board. 10 times. Is it 9 divided by 5?
Yes.
Minus 2?
Minus 2. 5 minus 2.
And
Yeah.
bracket.
And then 5 minus 2 is in parentheses.
Yeah.
No bracket on 10.
You put
9.
one in front of 9, and then you put one around 5 and 2.
And
And
then
there's parentheses here?
Yeah.
Yeah.
Okay. We didn't cover this, but it sounds like everybody understands that the raised dot means multiply. Everybody already knew that? The raised dot means multiply. In algebra, why do we go to the raised dot instead of the multiplication sign? Obvious?
Because for some equations you use x.
Right. So the raised dot means multiply. Now you got brackets here and parentheses inside the brackets. What am I going to do first? Z.
5 minus 2.
Innermost grouping. 5 minus 2 is 3. So I still got brackets out here. I got 9 divided by 3. Out here I got 10 times that. So if you weren't paying attention to your groupings, someone might go like this. 10 times 9, left to right, multiply and divide. But you can't because you still have brackets here. So you have to go inside the brackets first and do 9 divided by 3. So the final answer, because this becomes 3, now we've got 10 times 3, Cam,
30.
30. Yes?
It would be the same answer if you did 10 times 9 first.
Okay. Is it possible, Zach, that for some problems you might haphazardly stumble into doing it the wrong order and still get the same answer? Probably. But that's not always going to happen. Yeah. All right, let's do our first story problem. Did we have a story problem on any other things we did? Worksheets? No. Our first, listen to the groaning. Our first story problem. Number 6. Your friend, or 8. Your friend pledges $10 to you for fundraising walk and 25 cents each mile. I'm going to support you in your desire to raise money. I'm giving you $10, and for each mile you walk, I'm going to give you another 25 cents. How do we know how much money you're going to raise? I need to write an expression. I need to write a mathematical statement that is going to help me figure out how much money I make. Somebody help me out. What should I write on the board? Before I find out how many miles I walked, I need to write an expression that's going to help me figure out how much money I would raise no matter how many miles I walk. Bella?
$10 plus.
Stop there. Bella correctly has told me the first thing I'm gonna write is 10 plus something. Do you understand why? Because I'm getting $10 no matter what. I'm getting $10 if I walk like a tenth of a mile. If I start walking, she's pledging me $10. What am I gonna add to that?
25 times 6 in parentheses.
All right, forget the 6, because they already told you walk 6 miles.
Yeah.
Okay, the expression I'm gonna set up looks like this. $10 plus 25 cents times every mile I walk. Is it okay if I write M for mile?
Yeah.
Everybody look up here. Now we're getting into algebra. We're using a letter in our math. My expression is 10 plus 0.25. If I write a number right next to a variable, a letter, what's that mean? Case, if I write a number right next to a letter, what's it mean to do with those two? Multiply. So I've got 10 plus 0.25 times how many miles I walk. Now they tell us we walk 6 miles. So now this problem looks like this. 10 plus 0.26 or 25. You understand why I did it that way? I put them both in parentheses to kind of avoid confusion. I'm going to multiply, again, they're right next to each other. I'm going to multiply those two numbers together. Yes?
You're supposed to put them in parentheses.
Yeah, I did because to write 0.25 with a 6 next to it looks like 0.256.
Oh,
I could have put a raised dot in between 0.25 times 6. But oftentimes you'll see this. Put them both in parentheses to say, okay, you're going to multiply those two together. Everybody following this? So what's the answer? How much money does she get? She gets 10 plus. Now, if you have to, you go off to the side. You do 0.25 times 6. Wouldn't it be great if mental math, you can say, let's see, if I got 6 quarters, how much money would that be? I got $10, Sid, plus 6 quarters. How much is 6 quarters? Noah? $1.50. So my final answer, how much money did she get from that friend? Someone knew. Kiara?
$11.50.
$11.50. You guys done listening to me? You want to get to work so you get most of your homework done? All right, you're doing 10 through 20. Where's my cheat sheet? Then you're doing 21 and 29 through 31. I think I forgot one there. I did. 21, 24, 29 through 31. 10 through 20, 21 and 24, 29 through 31. I gave you these two, 21 and 24, just to give you practice with working with a fraction. You're doing order of operations, throw fractions in there, and then 24 is you're doing order of operations and we throw a decimal in there. So that you don't lose your mind and think, wait, order of operations apply to fractions too? Yeah. Remember, Noah, fractions are numbers too, right? Jaden.
Do we have to write the problem out?
Yeah. Guess what'll happen, Jaden, if you write the problem first? What'll happen to you physically?
Nothing.
No, you'll be fine.
Your hand might cramp a little.
Yes.
It might take you longer.
Why, Dominic?
I already did it.
Dominic, why am I having you write the problem down?
I already know
Really?
that.
Yes.
I have a question. You have to write out the story problems too.
That's a good idea, David.
No.
I'm kidding. No, you don't write the story problem.
That would take a long time.
Z,
Because we want to make sure that we're not using calculators.
If you look the problem, it's less than us too. You think about it.
Yes.
I forgot about that.
10 through 20. We just did 1 through 9 together. Actually, we didn't do 9, did we?
No.
Number 9, I think, is one of those where they say, hey, look at what that person did. Where'd they go wrong?
Oh, you remember that?
You don't have to do number 9 on paper. Number 9 is asking you to find out where that person went wrong. Can you easily spot it, Dina?
Do we have to do that?
Where they went wrong in number 9?
Did they not divide? Wait, I don't know. Yeah, I don't know. Not right now, but like a second.
Did you figure out where they went wrong?
They added
Yeah.
before they divided.
Yeah, they added, Dina, before they divided.
That's what I thought.
All right. Yes, sir.
I didn't tell you all the attorney.
So that I see that you let's say Z forgot to do his homework and he was all in a hurry and it was almost time for pre-algebra class and he said, let me see your paper, and you just wrote down a bunch of answers. I would never think Z would do something like that, but it's my job as the teacher to kind of like not lend you that temptation. You know, because we're humans. Sometimes we like to take the easiest way out. We almost always like to take the easiest way out. Yes.
I've got no clue how to do 12.
All right. That's what I like. Questions. Everybody's got a question on 12?
Yeah.
Yes.
It's so great to feel needed. I need to fix this situation. Usually I have a separate desk to hold my stuff. I got too much of a mess here. Number 12 says, what's it say?
16 over 7 minus 3.
16 over
16
7.
over 7 minus 3.
Is it like,
Yeah.
I think I think it's 7.
Oh.
I know how to do
Oh,
this.
we already did this now.
Yeah,
I did it.
I remember this.
That is a tough one. How do you handle that? 16 over 7 minus 3.
Yeah.
Yes.
You subtract 7 minus 3 and then you divide.
Okay, everybody understand what's going on here? I divide first? What am I
No, I
dividing?
was thinking either you divide first or you minus first.
Subtract.
Yeah, it's one of the two, right?
Yeah.
If I have 16 over 7 minus,
subtracted.
right?
Yeah.
Yes.
So you take 7 minus 2, that's 4, and then 16 divided by 4, you divide by 4.
Does that go against the order of operations though?
Yeah.
Yes,
That's
but it
not
doesn't.
right.
Like if they would have put parentheses here,
Then it'd be okay.
Yeah,
but they didn't,
They did.
but would you feel better about doing 7 minus 3 first?
Yes.
Yes.
You wouldn't? If they put parentheses there, wouldn't you be like, oh yeah, do 7 minus 3 first?
Yeah.
All right, let me ask you this. What if I rewrote this problem?
Yeah.
16 divided by 7 minus 3.
That's what I
Yeah.
put down.
I try to avoid these problems in the textbook. I missed this one. That's why I skipped over some of the other ones that get a little too complicated. But
No, that makes
is this and this the same thing?
Yes.
yes.
Is it? So is the answer 4 or not?
No.
No.
I
No,
got
no.
4.
You gotta go 16 divided by 7 is minus 3.
I got 4.
Right?
Divided by 4
It's 4.
Oh, that's right.
It's 4.
It's 4?
You get 4 if you do it like that?
No.
How would you get
No,
4 then?
of course
How do you
not.
get 4?
Because I got like a fraction when I did it.
Yes, you get negative.
How do you
Yeah.
get 4?
You just rewrote it. You didn't do the same thing.
I
So if you get 4 from that one, then you shouldn't get 4.
I'm pretty sure the book has 4. I know. I said it.
Okay.
Maybe you're supposed
But if you just rewrote it, that means that the book is so you should get more.
Maybe
Yeah.
maybe the two different
You know
copies.
what? I feel like it's four, but I'm confused.
I am too. We all.
Wait, it's what? Do you have 16 divided by 4? And then you minus 4. Okay, that's what I thought. I said minus 7. What if we do that? It equals 1 into the fraction. I did it already.
I said it. I just go.
Cyberspace.
How do you?
Look for that group setup on Google Classroom later.